Hi, let's go through this question. So the polynomial f of x of degree 3 leaves a remainder of 10 when divided by x minus 2 and remainder of minus 15 when divided by x plus 3. Yeah, okay. So find the remainder of f of x when it's divided by x plus 2, x squared plus 2, x minus 6. Okay, which can be factored as x minus 2 times x plus 3. Okay, so what you need to know, remainder theorem, factor theorem. Here they tell you remainder, so that means you just take the divisor, equate to 0, solve for x, get x equal to 2. Sub in into the f of 2 equals to remainder. Likewise with the x plus 3. Also f of minus 3 equals negative 15. Okay, knowing these two, we can carry on. Please ignore the previous working. It's not useful. What we need to know first before we can do this question is that the division algorithm here, f of x over d of x equals to q of x plus r of x over d of x. English names for it is dividend divided by divisor gives you quotient plus remainder over the divisor. Or if you multiply throughout by d of x, you get f of x equals to qx times dx plus r of x. Like when you multiply dx here, the dx will cancel. But maybe this does, in terms of notation, it doesn't make sense, so we should go for an example. So let's say we have x cubed divided by x squared plus 1. How do we find out the answer? How do you get this? Well, you just do long division, right? I will leave it to you to check that this working is correct. What we get at the end of the day is x here is your quotient, minus x here is your remainder, so you put it here, and then you must put over divisor. You can check it manually, add these two, and then you can get to the left hand side. Then you know that you're correct. I'll leave that to you to check. So the main point here is that dividend divided by a divisor gives you the quotient plus the remainder divided by the divisor. Okay, good. But you can now multiply throughout by x squared plus 1. Multiply left and right by x squared plus 1. You're left with x cubed equal x times x squared plus 1 plus negative x, which is your f of x equal q of x times d of x plus r of x. Okay, good. But what else do you notice in particular about this fraction here, minus x over x squared plus 1? Key thing to note, degree here, D-E-G-R-E-E, yeah, sorry, no space, I'll just put D-E-G dot, is just 2, right, highest power of x. Here, invisible 1, so degree is 1. What's the pattern? 1 less. Okay, the degree of the numerator, which is the remainder, will always be 1 less, 1 smaller than the degree of the denominator. That's the key pattern. Okay, so yeah, zooming out. So what did the question actually ask? They asked you to find out the remainder when f of x is divided by x squared plus x minus 6. Maybe let me just get rid of this subscript. Yeah, so what we have to write is use the division algorithm, which is above. If I can get it on the same page. Yeah, use this formula, but sub in d of x with x squared plus x minus 6. So f of x divided by x squared plus x minus 6 will be equal to some quotient, q of x. We don't need to know what it is, plus the remainder of x divided by x squared plus x minus 6. This pink color r of x is what we are trying to find. Okay, and we know that the divisor and the remainder, they have a relationship in terms of the degree. Denominator degree is a 2. Numerator, the remainders, degree will always be 1 less. Maybe I should also write down over here. Degree of remainder of x is usually 1 less than denominator. Or it's possible to be even less than 1. Oh, like for example, the divisor could be x cubed, and the numerator could just be a 1 as the remainder, which is 2 degrees less. This is degree 0, this is degree 3. Oh, in general, this is the rule. Degree of the remainder is always strictly smaller than the degree of the denominator, the divisor. So yeah, but you want the most general case, so you just go for 1 degree less. So that will be degree 1. And in general, r of x should be equal to ax plus b. It could be possible that the a is equal to 0, b is equal to 0. So you get 0x plus 0. So r of x would be equal to 0. So there's no remainder. Or it could be that a is equals to 0, b is equal to 1. That means your r of x equals to 1, which means it's 2 degrees smaller than x squared plus x minus 6. Those are all possibilities that can be covered, provided you write down ax plus b. So this ax plus b is the most general degree 1 format. So that's why we use ax plus b. Okay, then we can now substitute the r of x with ax plus b. Our goal now is to solve for a, solve for b. 2 variables, so how many equations do you need? You'll definitely need 2 equations. Then how do you get 2 equations involving a and b? You have to use back this information here. Previously they told us divided by x minus 2 you get remainder 10. So by remainder theorem we get this. Likewise, when you divide by x plus 3 you get remainder negative 15. So f of negative 3 equals minus 15. Using these 2 facts we can substitute into this equation. Then we can solve. We can solve. But before we do that, let's just simplify this expression a little bit. What we realize is x squared plus x minus 6 is coincidentally the same as x plus 3 times x minus 2. Okay, so I just factorize. And then I multiply throughout on both sides this denominator. What I'll be left with is f of x equals to q of x times x plus 3 x minus 2. Add on ax plus b. Here, okay, maybe I should also change it to x plus 3 x minus 2. So it's more obvious. This and this will cancel off eventually. Then you're left with ax plus b. Yeah. So now we can substitute in our 2 conditions. F of 2 equal to 10 and f of minus 3 equals negative 15. So when x equal to 2, you get f of 2 equal to 10. So f of 2 equal to 10, but we replace, but it's also equal to this entire expression, but we substitute x with a 2. What happens here is that you'll get a x minus 2, which is 2 minus 2, which is 0. So we don't even need to know what is q of 2. Doesn't matter. You just multiply by a 0, you get a 0. Then you're left with plus ax plus b. Substitute the x with a 2, what do you get? 2a plus b, exactly. Good. Then you do the same. Okay, then to make it look neater, I rewrite it as equation 1. 2a plus b equals to 10. But we are not done yet because we still got another information. F of negative 3 equals minus 15. So we sub in x equals minus 3, f of x equals minus 15. That's what I did here. But what is negative 15? It's also equal to f, where you replace all the x with a minus 3. So that's why I take a look at my f of x formula. In particular, the right hand side is also f of x. When x is minus 3, so I substitute the x there with minus 3. Sorry, this subscript 3 shouldn't be here. I've substituted the x with a negative 3, negative 3, negative 3, negative 3. You realize that minus 3 plus 3 is a 0. So multiplying by 0, this entire thing becomes a 0. Right, it becomes this entire expression becomes a 0. So it just disappears. 0 plus a times minus 3 plus b. Simplify, you get minus 3a plus b. Make it look neater lah. Then minus 3a plus b equals to minus 15. That's equation 2. You got equation 1, you got equation 2. Solve, simultaneous. You get a equals 5, b equals 0. You can check it yourself. Therefore, sub into the formula for r of x. A is 5, b is 0. You get 5x.